Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a 3D isometric projection corresponding to an engineering object into which the front view face, the top view face and the left hand side view face of the object, they have been appropriately combined into a single 3D isometric projection view over here. Now using the information available with us through this 3D isometric projection, we are required to obtain the front view orthographic projections, the top view orthographic projections and the left hand side view orthographic projections of the solid. Now, in order to obtain the orthographic projections of the solid, we are required to evaluate the dimensions of the front view face, top view face and the left hand side view face over here. Now, as we look at the solid from the front view orientation, now we observe that the total width of the solid has not been provided to us directly. We need to add different elements corresponding to this object in order to obtain the total width of the solid. So we have been provided with the information that the distance of the center point corresponding to the circular hole from the right hand side face of the solid, it happens to be 75 millimeter, and the center of the circular hole into the bottom horizontal width, it happens to be located at a distance of 15 millimeter from the left hand side face of the solid. So the total width of the solid, it will be equal to 90 millimeter. While we look at the solid from the front view orientation, the total height of the solid, it is also not provided to us. So now corresponding to this base horizontal width, the height happens to be 10 millimeter. Corresponding to this rectangular block which is resting on top of this horizontal wave of the base, this height of this rectangular wave happens to be 25 millimeter. So the total height of the solid happens to be 35 millimeter. So now we obtain the dimensions of the front view face as 90 millimeter by 35 millimeter. Now when we look at the solid from the top view orientation, so once again the width of the solid will be equal to 90 millimeter, while the depth of the solid, it will be equal to 25 millimeter plus 15 millimeter over here. So the dimensions of the top view face corresponding to the solid will be measuring 90 millimeter by 40 millimeter. And when we look at the solid from the left hand side view orientation, so now we observe that the depth of the solid, it is equal to 40 millimeter, while the height of the solid, it is equal to 35 millimeter. So the side view face will be having the dimensions 40 millimeter by 35 millimeter. So with this information, we are required to obtain the orthographic projections of this engineering object over here. So now we have drawn the XY reference line, the X1, Y1 reference line, and we have also obtained a transfer line originating from the intersection point corresponding to XY reference line and X1, Y1 reference line. And this transfer line has been obtained at an angle of inclination of 45 degree with respect to the XY reference line. And this transfer line we are going to use to transfer the distances from the top view projections alongside the depth of the solid into the left hand side view projections over here. Now since we are going to obtain the orthographic projections of the solid into the first angle projection method, so the front view projections of the solid will be obtained above the XY reference line. The top view projections of the solid will be obtained below the XY reference line, and the left hand side view projections of the solid will be obtained on the right hand side of the front view projections above the XY reference line. So let us proceed to evaluate the orthographic projections of the solid. So we know that the front view face of the solid is measuring 90 millimeter width by 35 millimeter height over here. So now here we have drawn two vertical projector lines into the front view projections separated by the distance 90 millimeter, which happens to be equal to the width of the solid. And these two vertical projector lines we have appropriately extended into the top view projections, because into the top view projections as well the width of the solid equal to 90 millimeter we are required to obtain over here. Next we know that corresponding to this solid we have got the height of the solid is equal to 35 millimeter. So we have marked this height of the solid equal to 35 millimeter into the front view projections, and we have obtained a horizontal projector line in the front view projections at a distance of 35 millimeter from the XY reference line, and we have extended this horizontal projector line into the left hand side view projections over here, because into the left hand side projection view also the height of the solid equal to 35 millimeter will be required over here. Next we have got into the top view projections. We know that the width of the solid it is equal to 90 millimeter, which we have already obtained, and the depth of the solid happens to be equal to 40 millimeter. So now we have drawn two horizontal projector lines which have been separated by the distance equal to width of the solid is equal to 40 millimeter. And these two horizontal projector lines we have transferred from the top view projections into the left hand side view projections using this transfer line over here. So this way we have been able to obtain the depth of the solid is equal to 40 millimeter into the left hand side projections, and we have been able to obtain height of the solid into the left hand side view face as 35 millimeter over here. So this way the front view face, the top view face and the left hand side view face of the solid have been obtained into the orthographic projections over here. Now let us evaluate the orthographic projections of the solid by dividing the solid into multiple elements over here. So the element number 1, it happens to be a horizontal wave which is lying onto the base of the solid, and this horizontal wave is carrying a central hole onto the left hand side portion of the solid over here. Then we have got a triangular vertical wave which is lying towards the rear face of the solid, and this triangular vertical wave it is lying parallel to the front face of the solid over here. Then we have got a rectangular block which is resting on top of this horizontal web over here, and this rectangular block it is resting towards the right hand side portion of the solid over here, and it is located towards the rear face of the solid. Now here we have got a semicircular hole having radius is equal to 15 millimeter. Now we know that the width of this rectangular block which is resting on top of this horizontal wave, it happens to be equal to 50 millimeter. So corresponding to this rectangular block width of 50 millimeter, we are going to mark a distance of 50 millimeter from the right hand side face of the solid. So we can check this rectangular block, it is located towards the right hand side face of the solid over here. So from the right hand side face of the solid we have marked a distance of 15 millimeter corresponding to this rectangular block, and we have obtained a vertical projection into the front view projection, and this projector line has been extended into the top view projections as well. Now another information we have that the width corresponding to this horizontal surface onto the right hand side, and this width corresponding to this horizontal surface onto the left hand side top surface of this rectangular block, it happens to be equal to 10 millimeter. So now from the right hand side face of the solid, we have marked a distance of 10 millimeter corresponding to this horizontal surface which is available at the right hand side surface of the solid, and we have obtained a vertical projector line into the front view projections, and we have extended this vertical projector line into the top view projections as well. Similarly, corresponding to this horizontal surface of the rectangular block, now we know that the width of this flat surface happens to be again 10 millimeter. So from the right hand side face of this rectangular block, this is the right hand side face of the rectangular block. So from the right hand side face of the rectangular block, we have marked a distance of 10 millimeter towards the right side, and we have obtained a vertical projector line into the front view projections, and this vertical projector line we have extended into the top view projections as well. Now we also know that the horizontal element, which is our element number 1, it is carrying a circular hole which is having its center at a distance of 15 millimeter from the left hand side face of the solid. So this is the left hand side face of the solid. So from the left hand side face of the solid, we have marked a vertical center line which is located at a distance of 15 millimeter from the left hand side face of the solid into the front view projections over here, and this center line we have also projected into the top view projections as well. And now we know that the diameter of this circular hole into the horizontal web, it happens to be 20 millimeter, or the radius of this hole is equal to 10 millimeter. So now with this center point, we have to take offset of 10 millimeter on the left side, 10 millimeter on the right hand side, so that this radius will be equal to 10 millimeter, or the diameter of the circular hole will be equal to 20 millimeter. So with this 20 millimeter diameter of the circular hole, we have projected two black vertical projector lines into the front view projections, and these vertical projector lines we have appropriately extended into the top view projections as well. Now we also know that the height of the horizontal web above the base of the solid happens to be equal to 10 millimeter. So this height has been provided to us as 10 millimeter over here. So corresponding to element number 1, that is the horizontal web, we have drawn a horizontal projector line at a distance of 10 millimeter from the base of the solid, or the XY reference line, into the front view projection, and this horizontal projector line we have extended it into the left hand side view projections as well. So now we can check, we have been able to obtain the height of this horizontal web as 10 millimeter. Now another thing, we know that there is a semicircular slot which has been cut towards the top surface of this rectangular block, and this semicircular slot is having radius is equal to 15 millimeter. So now at a distance of 15 millimeter from the top surface, we are able to mark a horizontal projector line into the front view projections, and we have been able to extend this horizontal projector line into the left hand side view projections as well. So now we have been able to obtain the extreme points which is equal to the distance 30 millimeter diameter corresponding to this semicircular slot over here. So this radius 15 millimeter also we have been able to obtain. So this will be our center point of the circular curve over here, having radius equal to 15 millimeter. We have marked a vertical central projection line into the front view projections, and we have extended this center projection line into the top view projections over here. So with this as the center point, now this radius, and this radius, it will be equal to 15 millimeter. So the edge view projections corresponding to the semicircular arc, they have been obtained into the front view projections over here. And now we can join the edges of the solid which are visible to the observer. Now we can check corresponding to this vertical surface of the element number 1, which happens to be the front face of this horizontal web. We will be able to observe a true shape rectangular projections into the front view projections over here. Similarly, corresponding to this front face of the triangular vertical web, which is resting towards the rear side of the solid over here. Since this triangular surface happens to be parallel to the vertical plane, so into the front view projections we will be able to obtain the true shape triangular projections in the front view projections over here. Next we have got this surface over here, this vertical surface corresponding to this rectangular block which is resting on top of the horizontal web over here. Since this surface of this rectangular block, it is also parallel to the vertical plane, so we have been able to obtain the true shape projection corresponding to the front surface of this rectangular block over here. Similarly, since this semicircular vertical surface corresponding to this rear side of the web over here, it is also parallel to the vertical plane. So into the front view projections, we have been able to obtain true shape projections corresponding to this vertical surface of this semicircular slot over here. Next we have got this circular hole. So this circular hole will not be visible to the observer from the front view orientation. So we will be able to obtain hidden line or the dotted line projections into the front view corresponding to this circular hole over here. So this circular hole will be projected as a apparent shape rectangular projections into the front view projections over here. And here we have got the hidden lines to represent that this circular hole is not visible to the observer from the front view orientation over here. Now let us proceed to evaluate the top view projections of the solid. Now as the observer is going to look at the solid from the top, so we observe that corresponding to this element number 2 over here, that is a triangular vertical web which is lying onto the rear side of the solid, and this back web corresponding to this rectangular block which is again having depth is equal to 10 millimeter. So we are going to observe that from the rear face of the solid, we have marked a distance of 10 millimeter and we have drawn a horizontal projector line at a distance of 10 millimeter from the rear face into the top view projections, and we have transferred this horizontal projector line into the left hand side view projections over here. Similarly, now another information we have with us that corresponding to the circular hole, the distance of the center point of this circular hole from the rear surface of the solid, it happens to be equal to 25 millimeter. So from the rear surface of the solid, we have marked a distance of 25 millimeter and we have obtained a horizontal center projection line into the top view projections at a distance of 25 millimeter from the rear surface, and this center projection line we have appropriately transferred into the left hand side view projections as well. So this way, this center point corresponding to the circular hole we have obtained, and now using this radius is equal to 10 millimeter, we have obtained the true shape of the circular hole which is available with us into the horizontal web which is lying onto the base of this particular solid over here. So next, when we are going to look at the solid from the top, so this rectangular outline projection, it will be visible to the observer from the top view projections over here. And another thing we observe over here, that this rectangular block which we are having at the top of this horizontal web, it is having depth is equal to 30 millimeter. So this distance of the rectangular block from the front surface of the solid will be equal to 10 millimeter over here. So now from the front surface of the solid, we have marked a distance of 10 millimeter, so that this front surface of the solid we are able to locate into the top view projections over here. So we have drawn a horizontal projector line at a distance of 10 millimeter from the front face of the solid into the top view projections, and this horizontal projector line we have transferred into the left hand side view projections over here. And now we can join this portion of the rectangular block which will be visible to the observer from the top view projections over here. So we can check this semicircular slot. It will be visible to the observer as a rectangular slot over here. So we will not be able to observe the true shape projections corresponding to the semicircular slot into the top view projections over here. Rather, what we have obtained? We have been able to obtain apparent shape rectangular projections corresponding to the semicircular slot which is available at the top surface of this rectangular block over here. Now we can also see that corresponding to the circular hole, we have to draw two horizontal projector lines using black color into the top view projections, and these projection lines we have transferred into the left hand side view projections over here. Why do we need to project these two projector lines into the left hand side view? Because as the observer is going to look at the solid from the left hand side orientation, so these two extreme ends of the diameter will be visible to the observer as hidden lines over here. So that is why the orientation or the location of these 2 points of the diameter need to be obtained into the left hand side view projections over here. So that is why these 2 end points of the circular hole we have projected it into the left hand side view projections over here. So now when we look at the solid from the left hand side, so we observe that the horizontal web will be visible to the observer from the left hand side view projections over here. So this way, this depth of the solid 40 millimeter, height of the horizontal web 10 millimeter. So this true shape rectangular projections, they are visible to the observer from the left hand side view projection corresponding to this face of the solid over here. Then this vertical edge will be visible to the observer, and corresponding to this rectangular block, we are going to observe that at a distance of 30 millimeter from the rear side face of the solid. So this is the rear side face of the solid. This distance happens to be, we can check, it is equal to 30 millimeter from the rear side of the solid. Now we are going to observe the true shape rectangular projections corresponding to this surface of the solid over here. So right now we can see this surface will be true shape which has been projected into the left hand side view projections over here. But deliberately we have not joined this as an object line yet, because right now we want to discuss about this semicircular slot which will not be visible to the observer from the left hand side orientation. So this vertical semicircular surface, it will be visible as an edge view, as a dotted line into the left hand side view projections, and then this base of this particular semicircular slot, so this will also be visible as a dotted line into the left hand side projections over here. So now we can check once again this semicircular slot which is available onto the top surface of this rectangular block. It will be projected as an apparent shape rectangular projections into the left hand side view projections over here. Now we see that corresponding to this edge of this vertical web over here, we are going to obtain object line projections over here. So this object line projection we can check once again. it is going to supersede the dotted line projections corresponding to this perpendicular semicircular segment of the slot, which is not visible to the observer from this end. So that is why the semicircular portion will not be depicted as a hidden line over here, because it has been superseded by this edge of the inclined surface of this particular triangular vertical web, which is lying towards the rear side of the solid. Now we observe that corresponding to this inclined triangular web, we have got a rectangular surface which is inclined with respect to the profile plane. And since this inclined rectangular surface, it is not parallel to the profile plane, so into the profile plane, we are able to witness or observe apparent shape projections into the left hand side view projections over here. And finally, this hole, it is also not visible to the observer from the left hand side view. So we are going to obtain dotted line projections corresponding to these two extreme ends of the diameter over here. So the extreme ends of the diameter we have already obtained. So now we are able to obtain hidden line projections corresponding to the circular hole which is not visible to the observer from the left hand side view over here. So this way we have been able to obtain orthographic front view projections, orthographic top view projections, and orthographic left hand side view projections corresponding to an engineering object, so for which the 3D isometric projections, they were available with us. So this is all for today. We are going to continue with further discussion regarding few more illustrative cases of orthographic projections of the solids into the coming lecture classes. So thank you very much. Thanks a lot.